Hello and welcome to Manifest Maths. In this session we're going to look at the intersection between quadratic functions and straight lines. It's a typical past paper question. You can see an example of this graphically below, where we've got a curve given by the equation y equals 14 plus 5x minus x squared, and then a line y equals x plus 2. And very often you might get asked to find the coordinates of intersection of the two of them. So these are the kind of questions we're going to look at today. On top of that, it's going to be useful to know your quadratic formula to solve equations. So if we just can jot this down, so your quadratic formula, if you have a quadratic of the form ax squared plus bx plus c, and we want to find where that's equal to 0, our quadratic formula gives us the following rule. So it'll be minus b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to be using the quadratic formula today. Sometimes you'll be able to factorize, and if you want to practice factorizing, then please look at the video that's on the playlist for factorizing quadratics. Okay, so let's jump in with this question. You can see from this question we've got two parts. We've got a quadratic function and we've got a linear function. Okay. Now, because they're both equal to y, this curve is equal to y and this straight line is equal to y, and y are obviously equivalent, then therefore this means that these two parts are equivalent. Okay, so step one would be to put these two functions equal to each other. So 5x squared plus 6x minus 7 is equal to 2x plus 3. And then to get it in the form such that it's quadratic equal to 0. So we're going to take the 2x and the 3 off the right hand side. That gives us 5x squared plus 4x minus 10 is equal to 0. So this is our quadratic equation, with a being equal to 5, b being equal to 4, and c being equal to minus 10. We're going to substitute it now into the quadratic formula, which remember is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. That gives us the following equation. X equals minus b, so minus 4, plus or minus the square root of b squared, so 4 squared, minus 4 times a, which is 5, times c, which is minus 10, all over 2a, which is 2 times by 5. We can do a bit of simplifying now, which gives us minus 4 plus and minus. 4 times 5 is 20, times by 10 is 200, and we've got a minus and a minus, so this will be a positive quantity. Square root of 16 plus 200 all over 10. And then finally, x equals minus 4 plus or minus root of 216 over 10. Now you can run this on your calculator to see what two solutions you get. So after a bit of number crunching, you get the two following solutions. Remember, it wants the answers to two decimal places. So the first one is 1.07. The second one is minus 1.87. Now, if you want to be able to display these graphically, it doesn't ask this in the question, but it might be a good idea to do so, just to improve our understanding. So we've got our x and y axis. Our first equation was y equals 2x plus 3. That's quite easy to plot because we've got an intercept of 3 and a gradient of 2. So let's say that's our intercept of 3. And then for every 1 across, we're going to go 2 up, which takes us to 5. So we have the straight line looking something like this. Now, the quadratic has got an intercept of minus 7, which let's just put it down here. Okay, and then we know that the one of the intercepts of the line and the curve is going to be 1.07, so it's going to be just about here, and the other one's going to be minus 1.87, so if that's minus 1, it says minus 2, so the other one's going to be around here. So we can then probably start to visualize what the quadratic will start to look like as well. Okay, looks something like that, only a better diagram. Okay, right, we're going to practice that now on the next slide. So there's 3 questions for you to try, all right, and I'd like you to pause the video and try these yourself. Okay, right, let's go through the first one then. So just like before, with the first question, we need to equate the 2 parts. Okay, so x squared plus 2x minus 3 equals x plus 1, and bring these 2 elements across to the left, which gives us x squared plus 1x minus 4 equals 0. A is 1, B is 1, and C is minus 4. Our quadratic equation becomes x equals minus 1 plus or minus 1 squared minus 4 times 1 times minus 4 all over 2a, which is 2 times 1. This gives us minus 1 plus or minus square root of 1 plus, because we've got a positive and a negative, plus 4 times 4, which is 16, all over 2, which gives us minus 1 plus or minus root of 17 over 2. We can then put these into our calculator to get our 2 solutions, which are 1.56 and minus 2.56. Okay, next question. So, same format. We've got x squared plus 6x minus 5, which we're going to equate to 2x plus 1. Left hand side x squared, take the 2x off, which gives us plus 4x. Take the 1 off, which gives us minus 6 equals 0. Our a is equal to 1, our b is equal to 4, c is equal to minus 6. Our quadratic equation becomes minus 4 plus or minus the square root of 4 squared minus 4 times 1 times minus 6 all over 2 times 1, or 2 times 8. That gives us x equals minus 4 plus or minus square root of 16 plus 24. 4 times by the minus, 4 times by minus 6 gives us minus 24, and the minus gives us the plus, all over 2. X equals minus 4 plus or minus 16 plus 24, which gives us 40, all over 2. And then we can plug these into our calculator to get our 2 solutions. Again, we wanted the 2 decimal places. This gives us the first answer of 1.16 and the second one of minus 5.16. Right, third question. Find the coordinates of the point of intersection of the curve 4x squared. So we have 4x squared plus 8x minus 3 equals 3x minus 1. Let's balance it to make it 0 on the right hand side. We take the 3 off the 8x, which is 5x. Now this time I'm going to add the 1 onto the minus 3, which is minus 2. A is 4, B is 5, C is minus 2. X equals minus B, so minus 5, plus or minus the square root of 5 squared minus 4 times 4 times by minus 2 all over 2a all over 2 times by 4. So we have x equals minus 5 plus or minus the square root of 25 plus, so 4 times 4, 16 times by 2 plus 32 all over 8. X equals minus 5 plus or minus the square root of 57 all over 8, giving us the following two solutions. So we get 0.32 and minus 1.57. Right, let's go back to the first question we saw at the beginning. Okay, what I want you to do now is pause the video and see if you can answer this question. It's a typical WJC exam question. And let's go through the solution. So we have the quadratic 14 plus 5x minus x squared and the line y equals x plus 2. So we're going to equate the two. 14 plus 5x minus x squared equals x plus 2. Now in this case, it's not going to be desirable to necessarily have the minus x squared on the left. So this time we're going to take everything to the right hand side. If I take the minus x squared over to the right hand side, we're going to have x squared. I've got 5x here, which if I take off the 1x here, it's going to give me minus 4x. And then if I take the 14 off the 2, that's going to give me minus 12. Now our a equals 1, our b equals minus 4, and our c equals minus 12. Our quadratic equation, x equals minus b. Now this is a question, b is already minus, so minus 4 will give us just 4. And we have the square root of minus 4 squared minus 4 times a, which is 1, times by minus 12, all over 2a, which is 2 times by 1. This gives us x equals 4 plus or minus the square root of 16 plus, because of the two minuses, 4 times by 12, which is 48, all over 2. This gives us the following: 4 plus or minus the square root of 64 all over 2, which gives us 4 plus or minus. Now this one you could run it through the calculator, or you could actually square root, which gives us 8 over 2. Sorry, there's no square root symbol there. My apologies. It's 4 plus or minus 8 over 2. So the first solution would be 4 plus 8 over 2, and the second solution would be 4 minus 8 over 2. The first one gives us 6. The second one gives us 4 minus 8, which is minus 4, divided by 2, minus 2. And you can see where these 2 points are graphically on here. This one, x is 6, and this one, x is minus 2. Okay. With this question, your quadratic that you end up with actually could have been factorized, so you didn't have to do the quadratic formula. All right, we could have factorized this and got these two results straight away. So for example, x plus minus 6, x plus 2. That's your factorized version of this quadratic here. Again, if you want to practice factorizing, please go back and look at the video on the playlist on factorizing. Okay. The next thing to think about now, perhaps, would be solving simultaneous equations. Perhaps this is a method of solving simultaneous equations, but solving linear simultaneous equations and maybe some of the stuff on coordinate geometry. Okay. Thanks for tuning in to Manifest Maths.